article. So guys, that's why I'm moderating today, because we are the bridge that connects all the scaling solutions for Ethereum.
Hi everybody, my name is Keone, co-founder CEO of Monad Labs. We're working on super high performance EVM, and I guess the thing that we do differently is we parallelize the EVM by rebuilding the ground up. It's a new layer 1 launching next year.
My name is Daniel Wang. I'm the co-founder CEO of Taiko. We are building a L2 ZK-Rollup, Ethereum ZK-Rollup.
Hey guys, I'm Shuyao. I lead business development at Consensus. So some of our products, many of you probably are using MetaMask. For developers, you probably use Infura. And then recently we launched a zkEVM that's aiming to be a Type 2 zkEVM end of the year called Linea. And happy to be on the panel, and I think we get the best moderator of the entire token planning for this.
All right. See a lot of familiar faces on the panel. My name is Kenny. I'm one of the co-founders of Manta Network. We are the only EVM-based L2 that supports ZK-enabled applications natively.
Okay, so let's dive into the panel. I know you heard a little question. Actually, I saw it today, but I'm gonna make a little modification on the original question. So, well, the first question goes to we have seen scalability of Ethereum. So we're building our layer 2s on Ethereum. So the multi-chain world has become to a world of Ethereum plus out layer 1s plus rollups on Ethereum. So where are the other rollups on other layer 1s that were in and the other out layer 1s? Where are they? Why do you choose to build on Ethereum? Or why are you choosing to provide another scalable Ethereum or still EVM compatible layer 1? So everything is centered around Ethereum. So why did you make that choice?
Yeah, I think the reason is that it's still pretty early right now, but right now when you're a rollup, you need data availability, and really the main source of data availability that's well accepted by the community is Ethereum. So I can see that over time there's other data availability solutions come to market, like Celestia, or IGA, or other such data availability solutions. Then there will be rollups that are not based on Ethereum, and then probably just become more common. So there will be rollups on other blockchains. And I guess the other thing that I would add is that for a rollup that's settled on Ethereum, because the finality of Ethereum is generally 12 to 18 minutes, 2 epochs. So that's a pretty significant amount of time. So there might be advantages to settling on a different DA layer to get back to finality for the roll.
So a lot of smart people have tried like state channels, plasma, sidechains, sharding. None of them work very well. So I think people are going to keep trying different approaches. But so far, I think this idea of verifying computation without redoing the computation is the big idea, which is the idea all the rollups are built upon, right? But I think the history is still too short, as I said elsewhere. We cannot just claim this is the best solution. It's the best solution so far. But who knows? Maybe there are new, math approach. I don't know. We cannot even imagine now. So yeah, we are. I think right now Ethereum is the best settlement layer, the most decentralized and secure base layer for rollups. But all the rollup idea technology can apply to another base layer. Ethereum is a better base layer. So we're not saying we should all stick to Ethereum, but of course I love Ethereum. The time will be mad at me if I say But we are recording it actually. But I'm saying we should be open-minded and just keep in mind that there are a lot of rooms for improvement even in the Ethereum specifications. So I really look forward to smarter people who still work on layer 1s as well. So we can have better layer 1s. So our layer 2s will be even better.
Yeah, I heard. Actually, Candace was talking to me the other day that Taiko is and you're able to build layer 3s on Taiko and layer 4s, layer 5s.
I can comment on that a little bit, sorry guys. So Taiko being a type 1 zkEVM, the protocol smart contracts can be like redeployed on top of Taiko without changing anything. But this really depends on we can generate type 1 ZK proofs. So using Taiko, you can build layer 3s. You can also build other Taiko layer 2s because our software is MIT licensed, fully open, so you can do whatever you want with it without asking us for permission.
Also, looking forward to Taiko 2049.
2049, no? Yeah, I think to me we're really early, right? So we're seeing like alternative layer 1 moving to EVM, rollups, and we're seeing more programming languages come into play as well. If we're like content and happy with where we are as an industry, I think we're dead pretty much. But we must continue to innovate. And I think there's room, definitely room for non-EVM. I think Starkware does a great job experimenting on that. So from a technology perspective, I think we're definitely early. But I want to step back because consensus, we also have the wallet side, right, MetaMask. Like really, no one cares what rollup you're on. Like normies do not care, they can't even pronounce it. So I think our job is to build a fantastic base layer so developers and devs can build use cases on top of it, and users can just use it. And whether that gets settled or what type of technology is used is like important.
It's interesting to see how those EVM people are talking about building layer 2s on other blockchains other than Ethereum. All right, Kenny.
Yeah, so one sort of thing that was kind of touched on, and I guess I'll go through each of these points. One is the security, right? Like right now, both on the infrastructure side as well as the economic side, there's nothing in comparison to what Ethereum has as a layer 1. And so by borrowing that security as an L2, right, like it's something that you don't have to worry about as much as you would in like a newer type of ecosystem. So I think from that perspective, you don't have to worry as deep in the infrastructure as you normally do. And so as an L2, you can think about other things such as like the higher level, such as like growing the ecosystem, et cetera. That's on the infrastructure side. And then I think data availability was mentioned as well. And I think data availability paired with the L2 is extremely powerful because if you decouple the execution layer from everything else, you can actually build in customizable precompiles into the execution, which optimize your environment for certain specific use cases, right? So for Manta, I had mentioned we're the only ones that offer, ZK-enabled application features natively through our chain. Right now, it's going through smart contracts. We're building it into the precompile, and that will optimize because we are a modular L2. We only provide the execution layer, and the data availability side is on Celestia.
All right. Well, the next question falls into ZK, since we have ZK people here. Well, the question goes when you think of rollups. Sure, let's go back from there. The question goes when you think of rollups, like why ZK? Why not other approaches? Talk about a lot these days, but still to our audience here, why ZK? What's the benefit?
Yeah, sure. So there's a lot of benefits. I'm not on the rollup side, so I'll let the people on the rollup side speak more to that. We are on the application layer, and so there's two components to the application layer that people think about. One definitely more than the other. The first one is around privacy, right? That's what people default to when they think about ZK, unless it's about rollups. But the reality is that ZK-enabled features unlock a whole class of applications that just either don't exist today or can't scale. And so I'll give you an example, right? So like the example I really love to use is gaming. Right now we think about on-chain gaming. It's really just centralized games with like NFTs and crypto. But if you really want to build on-chain games, there's two classes of games. The first one is the perfect information games. That's like a game of chess. You and I, we're playing a game of chess. I can say knight to d7, and you'll know exactly where the knight is because we know all the information that's available on the board. So that's perfect information. But then there's a class of games called imperfect information games, right? If you and I were to play a game of poker instead, how can we agree that the shuffle was done in the correct way, the card that you received is the correct card you should be receiving? I should agree that that's your card without knowing what your card is. That sounds familiar, right? That's ZK. And so enabling a new class of applications that simply can't exist on the blockchain today, that's what I think is really powerful about ZK.
Very smooth.
Good intro. Well, ZK is Vitalik said we're going to snarkify the whole world. Then we follow. No, not really. So the consensus zkEVM Linea, we started actually with ZK for privacy. The first code name for Linea was actually called Sumo. It was a privacy-oriented payment rollup, and now it become completely EVM compatible general purpose rollup. But to me, I think like a very simple answer, right? We're at a very early stage of exploring what ZK does. To throw some buzzword, everybody's talking about zkML, and I see there's a WorldCoin banner somewhere over there. We have no idea what ZK is going to do, but I think the idea of the whole zero knowledge idea provides a design space, right? Similar to the previous panel on account abstraction. Account abstraction is not a feature. It's a design space, and it allows us to think and then develop applications. So I think we don't really know what ZK is, but it does provide a framework for us, like implement things in a Web 2 world or Web 3 native world, like scanning your freaking eyeball and store something.
So as a rollup, you don't need ZK. You can be what's this called, sovereign rollup. You can just be a rollup without trying to convince layer 1 smart contracts anything. And you just play on layer 2 or layer 3 yourself without reading anything to the base layer, right? So you don't need any proof. And then when you need proof, you can use like a game theory, you can deposit something and you can claim this is the right thing. That's the optimistic rollup approach, right? And then you probably you don't like the game theory stuff. You say, okay, I want to trust in math. That's where you have to adopt ZK because there's no better alternative, right? So for Taiko, we realized one thing: not all the transactions, not all apps really need ZK level security. For example, if you just want to deposit $10 to buy certain equipment, some weapons in a game, you don't really need ZK, right? So optimistic rollup is good enough. So that's why we come up with this like unified hybrid design where you can have an action which is totally 100% or even 99.9% optimistic blocks, right? And then you can convert it into like having more ZK block and eventually becoming like a full ZK rollup. You don't have to do any hard fork. You can just tune one parameter gradually, and then you switch change the nature of the rollup. So ZK is also cool, actually. Working on ZK is fun, it's challenging for engineers who has talent. They feel like, hey, this is not something so easy to get done, and then they enjoy it more. I think that's a benefit.
Yeah, ZK is also more like another choice you can make when you do rollups and other techniques. Well, going to Mona, so what's your plan on supporting ZK on your chain? Do you have any ZK applications, and what do you think ZK brings to you as a rollup?
Yeah, on day one, Manta does not have any ZK involved at all. But one thing that I guess I wanted to mention is that one of the ways that Manta delivers really high performance is by separating consensus from execution within the singular blockchain. So the nodes come to consensus, they come to agreement about the official ordering of transactions, and then as they start to come to consensus about the next block, at the same time they execute the previous block's transactions on each node. And that gives a significant speed up. Really, it increases the execution budget substantially. And in the long term, we're exploring some ways to maybe move that execution completely off of those nodes. And so naturally, the way to do that would be through zero knowledge, because zero knowledge is really about proving that some elaborate computation that you've done produces a particular state transition, particular result, which is exactly the problem of having the execution on a different set of nodes, which the result happens.
Exactly. We're also trying to separate proof generation with the execution layer and the proof layer. Well, the next question comes to actually EIP 4844 prototype sharding. Since we're talking a lot these days, we also talked about at Ethereum Singapore. So what is your view on the prototype sharding and what changes it brings? What changes you need to make as layer 1s or layer 2s as rollups? What changes you need to make according to prototype sharding? And what benefits does that bring to your project?
So just to summarize EIP 4844, it's really a very stripped down version of the date sharding plan to introduce data availability sampling, powering the introduction of many blobs stored by the Ethereum network. So in proto-date sharding, I believe, I'm probably going to get the numbers wrong because I haven't looked at it in a couple of days. But it introduces, I believe, 4 blobs of 250 kilobytes every block, maybe. So it's like a megabyte per block, maybe a little bit more than that. It's not like a lot. So megabyte per block, but then a block is every 12 seconds, so that's 100. It's 1 megabyte divided by 12, so like 87 kilobytes per second. So that's 87,000 bytes. And then a typical transaction for an optimistic rollup is about 200 bytes. So 87,000 divided by 200 is like 400.
Testing everybody's math.
Yeah. So it's about. So it's basically introducing about. So it's basically introducing, I believe, about 400 GPS of throughput for all rollups that are, that are using Ethereum as a data availability layer. So definitely a big improvement, but I think, something that's really important is further either compressing the transactions so that they, each transaction eats less into that budget, or also, not having to actually commit the entire transaction, we're just committing the, which I think zk's had a better, much better chance of doing.
So totally agreed. I think the program sharding won't lower the fee by a lot, really 10 times on those. The full dunk sharding is really expected to lower the fee and make sure that if people have enough hardware, they can, if the supply is higher, then the stable market price will be going down. As of now, as you mentioned, every block only have a very limited small space, like this space. From an implementation perspective, the program sharding changed the way you use data. You use the block, not the cloud data, and you have to assume that you cannot never access the data directly. You can only get a digest of the data. This is going to have some impact to previous rollouts, like my previous project, Looping. We need to read the data, read certain bytes from the real cloud data, and now you cannot do that. So when we design this new protocol, Taiko, we always have to assume the data is not available anymore. You cannot read the data. So I think the 4844 opens the door, but whether this final full dunk sharding is going to be the best data availability solution, I'm not sure. It's yet to be verified, right? So it's great to see more data availability solutions there, so we can just opt in. But I didn't do much research. I don't really know whether the programming interface is similar or what. Hopefully, those solutions can share a common interface so that we don't have to choose protocol a lot. We can just configure it easily, and then the whole code base is to run as data.
Yeah, I think it's a really a product question, and I'm a little removed. So I'll simplify it. I think we are going to adopt 4844. We looked at other solutions like Sebastian and IDA. To be honest, as a rollup, we have all these other things to worry about. It's like not really a priority. We're just going to go with 4844. But I think Kenny probably has a great answer.
I think we already talked a lot about the 4844. prototype sharding. So I'm just going to give you guys more of like a high-level thing to think about. So let's move out 5 years from now, 10 years from now. Where do all the L2s and data availability and all this stuff sort of play out? Okay, so this is my mad scientist theory. Because you already see this in other spaces, specifically in cloud computing, right? Like, do you guys know about the concept of like horizontal versus vertical scalability? Okay, so vertical scalability is where you take a computer and you stick as beefy of a CPU on there as possible, and as beefy as a GPU on there as possible, and just max it out, right? It's like the most expensive MacBook Pro you can buy. And that most expensive MacBook Pro that you can buy could probably run more applications than the cheapest MacBook Air that you can buy, right? So like you take one machine and you try to max it out as much as possible. And I think what we're seeing right now is we're seeing a lot of that being played out. Whether it's on the L2 side, we're talking about scalability in terms of TPS, right? Like, let's be real, right? Like whether you have 4 TPS or you have 100 TPS or if you have 1,000 TPS, that's still not going to scale to millions of daily active users per day. That's redundant. But the point being, there's an alternative here. Rather than beefing up the machine, you can copy the machines over and over again. And I think we're heading towards that trend right now because, you know, the big question here is why so many L2s? And to be fair, I think L2s are headed towards a commodity. And once you have this homogeneous commodity, then if you're able to scale it out with other services being built on top, such as Rollup as a service, right? Being able to build ephemeral L2s to spin up when you need and spin down when you don't, then all of a sudden we solve the scaling solution, not by vertical scalability, by making more TPS or more room for DA, right? But instead we scale it out horizontally by making clones and load balancing between those clones. And so all these L2s can work together to truly make the application layer really scalable. And so that's my comment on the proto-dame sharding. I think like overall, essentially, I think it's a great temporary stopgap to move the problem a little bit more forward. But at the end of the day, right, as we continue to beef up the machines, I don't think that's enough. I think we need to think about these sort of scaling solutions, whether it be like the interoperability side, right, maybe evolving into load balancers or something. But ultimately, I think like, yeah, the horizontal scalability is really where the bread and butter is for scaling out applications and usage. So proto-dame sharding, great solution in the temporary. I think we're going to bump into the problem again, and that's how we solve it.
Yeah, I like the horizontal thinking you're providing, like we're providing interoperability. So one thing we do is that instead of scaling Ethereum, we make Ethereum available using Bridge, where you can actually move your assets, move your information, move your data around in all different chains, in all different layer 2s. Choose whichever chain you like, move to whichever chain you like whenever you want to. So that's another way of scaling. And also, I think intentions should be right because we are moving forward because of the technical problem aside, but we'll soon be able to see the most flat solution of horizontal scaling. It's gonna generate something using a game console. Well, going back to the panel. So here's the last question. It's very open-ended. So to our audience, well, what is your roadmap? What are you gonna bring to our space within the next 3-6 months? What do you expect? What's the most exciting thing about in the near future?
Yeah, sure. So I'll start. So with Manta Network, right, like one of the things that we're really focused on is just ultimately bringing that user experience from the sense of enabling ZK applications without having to pay for them. So right now, when you use ZK applications natively, they're very expensive because on the compute side, it just is pretty intense for the verification on the smart contract. And so we're trying to eliminate that, which is why we're looking at Celestia for modularized DA, which is why we're building the ZK circuits directly into the precompiles, right? So we're taking these steps to try to really enable the ZK-enabled application development because we truly believe that's the next generation of decentralized applications. And so, you know, hopefully it's just one small step in many in the right direction of enabling that next generation of applications which comes with ZK as well as the horizontal scalability that I just described.
Yeah, I think we found that block space are commoditized, Even though we have Linea or zkEVM, but we work with every other blockchain, right? We work with Optimism Arbitrum for the longest time and Polygon. I hope we work with you guys in the near future. So what really excites me isn't which chain is gonna do well. What really excites me is to bring novel applications to our MetaMask users, to our wallet users. So I'm hoping, by us working together, if you have applications like Izumi, thank you for inviting us. By working with other infrastructure players, we can bring it to the wider audience. I do think we need more killer devs, no matter it's in the finance space, social. Everybody loves gaming. I don't play game, I don't know. But I'm really excited just for all of us to help developers build cross-chain solutions or access to users and for people to actually experience why they're on blockchain rather than on a database.
So Taiko is going to launch the next testnet very soon, actually 1 week later this month. So we are going to work together to run some campaigns. What really excites me is two things. First, we are going to deploy another testnet 1 month later with this hybrid rollup design to combine the optimistic rollup and ZK-Rollup. So that's something that I really feel excited. The other thing is this multi-ZK approach. So right now we are working with Ethereum Foundation's PSC group on this project called zkEVM. Later, after we have more circuits integrated in Q4, we are going to try different approaches, like risk zero zkEVM approach or some zkEVM approach to make sure we don't have the right circuits. We just write the guest Rust program and encode all our programs there and try to use this general purpose like zkEVM to generate rules. Of course, it's going to be more expensive initially, but that's the I think that's the way to go in the long run.
The thing that Monad does that's unique is Monad rebuilds the EVM execution stack from the ground up, enabling parallel execution and more generally enabling pipelining through multiple layers of the stack in order to deliver really high performance EVM. So we'll be launching our testnet before the end of this year with 10,000 transactions per second, single slot finality, 1 second block times. And then mainnet mid next year. It's kind of the main thing that we're looking forward to the next 3 to 6 months.
Awesome. Well, that be the end of the panel. Let's give a round of applause for our panelists. And I'll give the stage back. Hopefully, technical issues resolved, and you can see how crazy attention can be on ZK groups.